This lesson is more similar polygons. In the last lesson, we looked at similar polygons and how to solve for missing measurements using proportions. And now we're going to do the same thing using something called the scale factor between the two figures. So a similar polygon are polygons with the same shape and different size. So if we had two right triangles, and if those right triangles were similar, all of the corresponding angles are congruent and the sides are proportional. So if this triangle was ABC, and if it was similar to triangle DEF, we could write a statement saying triangle ABC is similar to triangle DEF. And that statement alone tells me which angles are congruent. It tells me that angle A is congruent to D, B is congruent to E, and C is congruent to F. It also tells me which sides are corresponding or proportional. So this side here, AB, is proportional the first two with the first two here, DE, and that angle or side AC lines up with DF, and BC lines up or is proportional with EF. Okay, let's look at our first example. Determine the common ratio of quadrilateral EFGH to quadrilateral ABCD. I'm going to have to scroll up enough to cut off that A right there. So I'm going to go ahead and put an A here because that is the name of this first triangle or quadrilateral. So EH corresponds, this side here corresponds with side AD. And the measurements on EH is 5, and the measurement on AD is 10. So this is how we find our common ratio. The order matters. It tells us we're going from this one to this one. So we have to put it in that order. We're going from the smaller one to the bigger one. So side CB lines up with side FG, and our measurements are 3/6. Side DC lines up with HG, and our measurements are 4/8. And FE lines up with AB, and our measurements are 2.5/5. So what they mean by a common ratio is that if we simplify each of these fractions, we get 1/2. So if our figures are similar, the ratio of all of their sides are going to be the same. So, and again, it matters which direction we're going. When they ask for the common ratio, you just take the first one and put it on top, and the measurement of a corresponding side of the second one and put it on the bottom. All right, let's look at the next example. Determine the common ratio of quadrilateral WX YZ to EFGH. We see these aren't drawn exactly in the same orientation, but we see that W lines up with E. So maybe I will just kind of redraw this one over here because here's E, so let me put W in that same place. So that would make this X, Y, and Z, and so Z is 125 degrees. And between W and X is 10. Okay, so we can see here that the sides that line up or correspond are this side and this side. And when it asks for the common ratio, it's asking us to go from this one to this one. So that gives me 10/2, which simplifies to 5. Okay, now we're going to talk about a real important term called the scale factor. Well, the scale factor is the ratio of the lengths of two corresponding sides of similar polygons. How it relates to the common ratio is it is actually the reciprocal of the common ratio. So if the common ratio here is 5, the scale factor is going to be 1/5. Well, what the scale factor tells us is what do I multiply by one number to get another number. So if I'm looking at the example above and I want to know what do I multiply by this side here, which is 10, to get 2. Well, what you have to keep in mind is if you're going from a bigger figure, one that has a side length of 10, to a smaller figure, a side length of 2, you're going to have to multiply by a number between 0 and 1. In other words, you're going to have to multiply by a fraction to get from bigger to smaller. So 10 times 1 over 5 gives me 2. If I want to go in the opposite direction, if I'm looking at a smaller number and I want to get the measurement of a bigger number, I have to multiply by a number larger than 1. So 2 times 5 gives me 10. So the scale factor is going to be the reciprocal of the common ratio. And what I do when I look at two similar figures is I just go ahead and find two sides that correspond, and I see a 2 over 10, and I know my scale factor is either 2 over 10 or 10 over 2. It depends on which direction I'm going. So let's look at the other measurement that we're given here. We're given a 3 here. And if we're looking for what is this measurement here, which is a side that corresponds, well, I'm going from a smaller one to a bigger one, so I'm going to multiply by 5, and it's going to be 15. If I wanted to go in the opposite direction, 15 times 1 over 5 is 3. Let's look at some more examples. Okay, so quick check. What is the scale factor of quadrilateral WXYZ to EFGH? So we are going from the big one to the small one. So again, 10 times 1 over 5 gives me 2. I have 10 over 2 or 2 over 10, which is 5 or 1 over 5. So 10 times 1 over 5 gives me 2. 3 times 5 gives me 15. Let's look at the next example. If quadrilateral JKLM is similar to quadrilateral NOPQ, first thing I notice is that this J lines up with the N. So here's J and here's N. So they are not drawn in the same orientation. So I'm just going to redraw the smaller one. So I have JKLM, so it's NOPQ. And the measurement 3 goes between N and Q, and the measurement 4 goes between N and O. So now I see that the sides that correspond are this one and this one. So my scale factor is either 10 over 4 or 4 over 10. And we can simplify that to 5 over 2 or 2 over 5. Now my question is, which direction am I going? And they want us to go from the big one to the small one. So what do I multiply by 10 to get 4? Well, that has to be 2 over 5. Now, if they were going to ask me what is the measurement of this side right here, well, then I'm going to have to multiply by the bigger number, which would be 5 over 2. So 3 times 5 over 2 gives me the missing side here. 3 times 5 over 2 is 15 over 2, or 7.5. Okay, we're going to look at this picture here, and first we're going to, well, it says complete the similarity statement. We can see that the two figures are drawn in the same orientation by looking at the angles that are congruent. So we know that triangle EFGH, or sorry, quadrilateral EFGH is similar to quadrilateral ABCD. What is the common ratio? Well, if we're going from EFGH, the bigger one, to the smaller one, we look for the sides where we have corresponding sides and we have measurements of both. Okay, so it would be this one. So if we want to go from the bigger one to the smaller one, it's 10 divided by 2.5, which simplifies to 4. Okay, so I would tell you now that the first thing I look at is if the common ratio is 4, that means my scale factor is 1/4. But my scale factor is either going to be 4 or 1/4, depending on which direction I'm going. So if I want to get a larger number, I'm going to multiply by 4. If I want a smaller number, I'm going to multiply by 1/4. So when we're first looking for x, that is the smaller figure. So I'm going to multiply 12 by 1/4, and I'm going to see that x is 3. Okay, again, z is on the smaller one, so I'm going to take 5 and multiply by 1/4, and I'm going to get 5 over 4, or 1.25. And then on y, I'm going from 2 to a bigger figure, so I need to multiply by 4, and I get 8. So the scale factor depends on which direction you are going, if you need to get bigger or smaller. Now the next questions that it asks, I'll go ahead and let me clear this and scroll down and show you. It's asking us to compare the perimeter of the two figures, okay? So let's go back up here and see what were the perimeters. So let's see, this was 3, this was 1.25, and this was 8. So if we just add up all the sides here, we get 8.75, and if we add up the sides over here, we get 35. So when we're comparing our perimeters, we're going to compare 8.75 to 35. So I'm going to scroll down, and this was 8.75, and this was 35. So if we're going to compare the ratios, 35 to 8.75, we're also going to get 4. So the ratio of the sides to the ratio of the perimeters are going to be the same in similar figures. Let's look at our next example. It says use the similar figures below to answer the questions that follow. Let's look at the questions. We want to know what's the common ratio, and we want to find x and y. Okay, so in this figure here, we see that they've lined them up in the same way, and so the similarity statement A, B, C, D, E would be similar to R, S, T, U, V. Okay, now when I'm looking for my scale factor, again, I just take the two sides that have measurements, and it is either 18 over 4 or 4 over 18, just depending on which direction I'm going. Now that simplifies to 9/2 and 2 over 9. So if I am looking for x is on my bigger figure. What do I multiply by 3 to get a bigger number? Well, it's going to have to be 9 over 2. 3 times 9 over 2 is 27 over 2, or 13.5. Okay, but what about y? Okay, well, on this one here, I'm going from a smaller one to a bigger one. So my scale factor again is going to be 9/2. So I'm going to take the smaller number 5 and multiply by 9 over 2, and that is going to give me y plus 2. Some might find it easier on this one to go in the opposite direction. I know if I take this one and multiply by 2 over 9, I can get 5. So I could also say y plus 2 times 2 over 9 is going to be equal to 5. So those will both work. Let's look up here. So I'm going to get 45 over 2 equals y plus 2. Okay, I should probably clear a little of this so it's not. Let me erase a little here to give us a little more room. Okay, so now if I multiply both sides by 2, I can get rid of my fraction. Maybe we'd like to do that. 2 times 45 over 2 is 45. And then multiply 2 times y and 2 times 2, and you get 4. If you subtract 4 from both sides, you get 41 is equal to 2y. and divide both sides by 2, and you get 20.5